Grounding raised floor supports in data processing rooms is required. This is primarily for safety and to ensure proper functioning of sensitive electronic equipment. The purpose of grounding and bonding is to create a low impedance path for fault currents, which helps to quickly trip over current protective devices like circuit breakers or fuses in the event of a fault. This minimizes the duration of the fault and reduces the risk of electrical shock or fire. In a data processing environment, the equipment is extremely sensitive to voltage fluctuations and electrical noise. Proper grounding and bonding help to maintain a stable and clean electrical environment, preventing data corruption, equipment malfunction, and downtime. The requirements for grounding and bonding are typically found in electrical codes such as the National Electrical Code, or NEC. While specific requirements may vary based on the year and adoption of the code as well as local amendments, the general principles remain consistent. Section 645 of the NEC specifically addresses information technology equipment and associated wiring in information technology equipment rooms. This section often references Article 250, which covers grounding and bonding in general. Grounding refers to connecting an electrical circuit or equipment to the earth or a conductive body that serves as earth. Bonding refers to connecting different metallic parts together to create an electrically conductive path. In the context of a raised floor, the supports are typically made of metal, and they should be bonded together and connected to the building's grounding electrode system. This ensures that all metal parts are at the same electrical potential, minimizing the risk of voltage differences that could cause problems. The structural steel of the building is often used as part of the grounding electrode system. It provides a large conductive mass that is connected to earth, providing a low impedance path for fault currents. Connecting the raised floor supports to the structural steel helps to integrate the floor into the overall grounding system. There are several reasons why grounding and bonding the raised floor supports are important. Firstly, personnel safety. If a fault occurs and a live wire comes into contact with a metal part of the raised floor, the grounding system provides a path for the fault current to flow back to the source. This causes the overcurrent protective device to trip, de-energizing the circuit and preventing electrical shock to anyone who touches the floor. Secondly, equipment protection. Sensitive electronic equipment can be damaged by voltage surges or electrical noise. A properly grounded and bonded raised floor helps to minimize these disturbances, protecting the equipment from damage and ensuring reliable operation. Thirdly, code compliance. Electrical codes mandate the grounding and bonding of electrical systems and equipment, including raised floors in data processing rooms. Failure to comply with these codes can result in fines, penalties, and insurance issues. The NEC provides detailed requirements for grounding and bonding. Some key considerations include the size and type of grounding and bonding conductors, the methods of making connections, and the location of grounding electrodes. Grounding conductors should be sized according to NEC Table 250.122, which is based on the rating of the overcurrent protective device. Bonding jumpers should be sized according to NEC 250.102. Connections should be made using approved methods, such as listed connectors, exothermic welding, or other means that ensure a permanent and reliable connection. Grounding electrodes should be installed in accordance with NEC 250.52. Common grounding electrodes include metal underground water pipes, metal building frames, and ground rods. The grounding electrode system should be interconnected to form a low impedance path to earth. When installing a raised floor, it's important to follow these steps. 1. Inspect the supports. Ensure that the supports are made of a conductive material such as steel. 2. Clean the surfaces. Remove any paint, rust, or other coatings from the surfaces of the supports where connections will be made. 3. Install bonding jumpers. Connect the supports together using bonding jumpers. The jumpers should be sized according to NEC 250.102 and installed in a way that minimizes impedance. 4. Connect to the grounding electrode system. Connect the raised floor to the building's grounding electrode system. This can be done by connecting to the structural steel, a grounding bus bar, or other approved grounding electrode. 5. Test the grounding system. After installation, test the grounding system to ensure that it meets the requirements of the electrical code. This can be done using a ground impedance tester. Common grounding and bonding mistakes should be avoided. One is inadequate conductor size. Using undersized grounding or bonding conductors can result in a high impedance path, which can impede the flow of fault current. 2. Loose connections. Loose connections can also increase impedance and reduce the effectiveness of the grounding system. 3. Improper bonding methods. Using unapproved bonding methods can result in unreliable connections. 4. Failure to connect to the grounding electrode system. Failing to connect the raised floor to the building's grounding electrode system can compromise the safety and performance of the electrical system. There are several benefits to properly grounding and bonding a raised floor. Firstly, improved safety. Grounding and bonding help to protect personnel from electrical shock and reduce the risk of fire. Secondly, enhanced equipment protection. Grounding and bonding help to protect sensitive electronic equipment from voltage surges and electrical noise. Thirdly, code compliance. Grounding and bonding help to ensure compliance with electrical codes. Fourthly, reduced downtime. Grounding and bonding help to prevent equipment malfunctions and downtime. When troubleshooting grounding and bonding issues, several steps can be taken. 1. Inspect the connections. Check for loose, corroded, or damaged connections. 2. Test the grounding impedance. Use the ground impedance tester to measure the impedance of the grounding system. 3. Verify the conductor size. Ensure that the grounding and bonding conductors are sized correctly. 4. Check for ground loops. Ground loops can cause electrical noise and interference. To avoid ground loops, ensure that there is only one connection to the grounding electrode system. There are several tools and equipment that are commonly used for grounding and bonding. Firstly, bonding jumpers. These are short lengths of wire or cable used to connect different metal parts together. Secondly, grounding connectors. These are connectors specifically designed for making grounding connections. Thirdly, ground impedance testers. These are instruments used to measure the impedance of the grounding system. Fourthly, exothermic welding equipment. This equipment is used to create permanent, low-resistance connections. Grounding and bonding are essential for the safety and proper functioning of electrical systems, particularly in data processing rooms with raised floors. By following the requirements of the electrical code and best practices, you can ensure that the raised floor is properly grounded and bonded, providing a safe and reliable electrical environment. It is always recommended to consult with a qualified electrician or electrical engineer to ensure that grounding and bonding systems are designed and installed correctly. They can assess the specific requirements of the installation and provide guidance on the best practices for grounding and bonding. Remember that electrical codes and standards can change, so it's important to stay up to date on the latest requirements. This ensures that grounding and bonding systems are installed and maintained in accordance with current regulations. Proper grounding and bonding are critical for protecting people and equipment from electrical hazards.